Okay, today we are going to be teaching a lesson on derivatives. If you don't know what a derivative is, it is just the slope of the tangent, which as you can see is just a line intersecting a single point on a given curve. The slope of that is the derivative, and also it's the instantaneous rate of change, which is different from the average rate of change because it's just the rate at a single point versus over the span of the whole graph.
Today we will be teaching you the different rules of derivatives, which will help you compute derivatives. We will be doing this with the help of Bruce, the derivative goose.
Okay, so the first rule we'll be learning today is the power rule. This is how to take the derivative of any variable with an exponent, like x squared or x cubed or x to the fourth, and so on. How you do this is you take any variable with an exponent, let's say x to the fourth, and you move the exponent to the front of the derivative, so it would be 4x to the fourth. Then you take the exponent and you subtract 1, so it would be 4 minus 1 equals 3. Now what you have is 4x to the third, and this is your derivative. Another aspect of the power rule is what to do when the exponent of your variable is 1. In a regular power rule example, such as x squared, you would just move the 2 in front of the x and make it 2 minus 1, and it would become 2x to the first power. But what if the example is 4x to the first power? This would become 4x to the 0th power, and x to the 0 is 1, so it would become 4 times 1, which is 4, and you're left with the constant.
So another important factor of derivatives is constants. It's not exactly a rule, but if you don't know what a constant is, it's just simply a number without a variable, like 5 or 206. It doesn't really matter. But the point is that if you have a function, say f of x equals 2x plus 5, and you want to take the derivative of it, it's just going to end up being 2, and you're going to completely ignore the constant. Basically, if you take the derivative of a constant, it's going to be 0. So another important fact about constants is that you're basically just going to leave them alone and carry on with your other rules until you're finished computing the rest of it. So for example, right here you see a variable and an exponent. So what you're first going to do here is do power rule. So you're going to do your typical moving the 4 to the front, subtracting 1 to get 4x to the third. But you still have the 5 here. So what are you going to do with it? You're just going to bring it in front and multiply it. So you're going to end up with 20x to the third.
Alright, so the next rule we're going to be doing is product rule. So for this rule, you're going to have the function f of x, and you'll have two smaller functions, which it could be 2 or more. So these will be represented by u and v. So when you take the derivative of f of x, the rule is you have to do u times the derivative of v plus v times the derivative of u. So for example, if you have x squared minus 1 and x plus 5, what you're going to have to do is, this is the u and this is the v. So you take the u, which is x squared minus 2, minus 1, just kidding, and then you multiply it by the derivative of x plus 5, which in this case is just going to be 1, and then you add v, so the x plus 5, by the derivative of u, which is just going to be 2x. So then you just do all the math, so you're going to have x squared minus 1 because you're just multiplying by 1, plus 2x squared plus 10x. And then you add the x squared plus 2x squared, and then you have plus 10x minus 1, and that's going to be the derivative.
So the next rule we're going to go over is the quotient rule. This is basically how to take the derivative of a function that represents itself as a fraction, with something on the top and something on the bottom. So the trick we're going to use is high, ho. High is the top and ho is the bottom. The rule here is ho derivative of high minus high derivative of ho all over ho squared. So to give an example, the function 4x plus 3 over 2x would be solved like this. Okay, so ho is 2x, and the derivative of high is 4, minus high is 4x plus 3, and the derivative of ho is 2, all over 2x squared. So 2x times 4 is 8x, minus 4x plus 3 times 2 would be 8x plus 6, and then you distribute the minus, which would become 8x minus 8x minus 6, all over 4x squared. So 8x minus 8x cancels each other out, and it's minus 6, or negative 6, over 4x squared. This can be simplified to 3 over 2x squared, and it would be negative. And this is your derivative.
Okay, so an idea central to taking derivatives is the idea of the chain rule, which basically means that if you have a function and then a function inside of it, you're first going to take the derivative of the outside function, say just f, and then you're going to leave g of x inside just alone, just as it is, and then after that you're going to multiply it by the derivative of the inside. So you're going to take the derivative of g of x. So I'm going to show you an example. So say we have the function f of x equals 3x plus 5 to the 4th power. So initially you're going to think power rule, which is right. So you're just going to take 4 times 3x plus 5 to the 3rd, as you normally would. But then you're going to take the derivative of the inside. So it's just going to be 3 in this case. And so your final answer is going to end up being 12 times the whole thing. So another important little unique aspect of derivatives is the e to the x function. So when you take the derivative, it's super easy. It's literally just going to be e to the x. So, yep, there's no change there. But a special example would be if the x had something attached to it, say e to the x squared. So when you take this derivative, you're going to use some of the chain rule you just learned. So you're going to have e to the x squared, since the derivative of e to the x is just the same thing it was. And then you're going to take the derivative of the inside, which is 2x. So your final answer is going to be 2x e to the x squared.
All right, so another part of taking derivatives is trigonometry. So, for example, if you have sine of x, when you take the derivative, it's going to be cosine of x. And then for cosine of x, it's going to be the same thing. You're going to take it and it'll be sine of x, but it's going to be negative. And then for cosecant of x, it's going to be negative cosecant of x cotangent of x. Yes. And then it's going to be secant of x tangent of x for the derivative of secant. And then the derivative of tangent of x is just going to be secant squared of x. And the derivative of cotangent will be negative cosecant squared of x.
So commonly used with chain rule is the trig that we just learned. So I'm just going to show you a few examples. So here we have sine of 3x. So as you learned, we're first going to take the derivative of sine, which is cosine. And we're going to leave the 3x in the inside. And then we're going to take the derivative of the inside, which is 3. So your final example is going to be 3 cosine of 3x. Similarly, in this little more complicated example, we're going to take the derivative of cosecant, which is going to be negative cosecant x squared cotangent x squared. And then we're going to take the derivative of the inside, which is 2x. So our final example, our final answer is going to be negative 2x cosecant x squared cotangent x squared. Go. So another part of trig is when you take the inverse of them, it's going to be a different derivative than maybe what you'd expect. They're kind of really long and complicated. So I'm going to show you them. So if you don't know what inverse means, it's basically just when the function's represented by like a -1 or it starts with an arc. So inverse sign to start off is going to be 1 over square root of 1 minus x squared. And then cosine, which is kind of like its counterpart, it's basically going to be the same thing, just negative. Secant is going to look kind of the same, but it's going to be 1 over the absolute value of x times square root of x squared minus 1. And then again, counterpart, cosecant, going to be the same thing, but negative. And then the last two are the easiest, basically. Tangent's going to be 1 over 1 plus x squared, and cotangent's going to be -1 over 1 plus x squared.
Thanks for watching. We hope you learned about derivatives.